Hello everybody, welcome back to Zeta Factor, and today I am going to focus on solving the next mathematical problem. And similarly to what I did in the last video, I will also be solving the Diophantine equation, which means this would be an equation where we need to find integer solutions. So this time I also took the problem from my favorite book, which is 25 Years of Mathematical Gazette Problem Corner. And this problem specifically comes from Mathematical Gazette volume 83 from 1999. Here's the problem. So given this Diophantine equation, n in power n minus 1 minus m in power n q plus m in power n minus 1, find all the solutions for q, m, and n more greater than 1. So again, I didn't look into the solution for this problem, so it would be a little bit of like thinking from my side and kind of like exploring different approaches. And as usual, I don't really know the right solution to this problem, so like my solution here would be completely wrong. But that's okay. I think I really want to show like the way how I solve the problem and kind of see where we can progress. So let's start. All right, let me write it down again. Okay, q n plus 1 minus m power nq plus mn minus 1 equals 0. Okay, so we final solutions when q, m, and n more than 1, and then because it says it's a Diophantine equation, we assume that q, m, and n all integers. All right, let's rewrite this to maybe try to simplify this in some way. Qn plus 1 minus 1. Yeah, we will write it because those have same powers, so we will do it like this: mnq minus mn, which will give us this. Okay, and then we use like a well-known formula for q in the power of n minus 1, which would be basically q minus 1 qn plus qn minus 1 plus 1. This is equals m power of n q minus 1. So because q more than 1, which means q does not equal is 1, we can divide both sides by q minus 1, which would mean qn plus qn minus 1 plus etc. equals m in the power of n. So this is a Diophantine equation we now need to solve. All right, how are you gonna solve it? All right, let me think about it. Okay, maybe we'll do like another transformation. Actually, I can see that we can apply like similar formula, but now for m in power of n minus q power of n. So let's do this. So we keep here these elements, m power of n minus q power of n. Okay, this can be like written in a similar way, basically m minus q, m n minus n plus m n minus 2 q plus etc. plus m qn minus 2 plus qn minus 1. Okay, so here we go. This is interesting one. So again, we assume that m, q are integers and both of them are more than 1. So like we have this m minus q here, right? So like let's see, can m minus q be less than 0? No, it cannot. Why? And this is because if m minus q less than 0, we know that both q and m are more than 0, so both equations in the left side and then the right side are more than 0. So this is a contradiction. So m minus q cannot be less than 0, which means that like here it's for sure then m is more than q. But also, okay, it cannot be 0. It can be less than 0. So which means basically that m minus q more than 1, which is great. I think it's something. M minus q more than 1. Okay. I'm thinking how we can represent this, the right part here. Right, I think it's kind of like very straightforward, or maybe not. So if you write like what's written in these brackets, right? This equation, let's rewrite it as like starting from q minus 1 plus mq n minus 2 plus etc. plus mn minus 2q plus mn minus 1. If you think about this, we know that m is more than 1, right? Which means that m in the power of I will be more than 1. It's pretty clear that like this thing is more than q n minus 1. If you replace every m with 1, would be 2 plus etc. plus 1, which is basically the left side here. And then we know that m minus q more than 1, which means that the right side of equation m minus q n minus 1 plus mq n minus 2 plus etc. mn minus 1 strictly larger than 1, because this is more than equals 1, q n minus 1 plus 1. So because it's strictly larger, it cannot be equal, so it never equals to that, and then we get a contradiction. It means that like original equation is not solvable, so which means that we have no solutions for any q m n more than 1. I think that's it. That should be it. There's no solutions for any q, m, and n. And now I will make a pause and look into the solution of this problem and verify if my chain of thoughts was actually correct. Give me a moment, please. Okay, so now I'm back, and then I'm now ready to present you an official solution for this problem from the book of 25 years of Mathematical Gazette Problem Corner. Just before we start, I just want to say that I got the same outcome as the book says. So basically it was a correct solution, correct answer. I got a correct answer that there are no solutions to the original question. However, they gave a much nicer and more neatly written solution, which I really want to present here. So, from given equation, they say that qn plus 1 equals m in power of n, q minus 1, same as me. So, because q more than 1, we derive that m in power of n equals q power of n plus etc. plus 1. Okay. But here they, whereas it's like much nicer and neat solution, they say that like q power of n, of course, it's less than q power of n plus q power of n minus 1 plus etc. plus q plus 1. And this is also less than q plus 1 its power of n. And why is this? And this is because in this formula, if we open the brackets, there would be binomial coefficients, and all of them binomial coefficients in this formula would be more than 1, and n would be more than with n more than equals of 2, which basically means that this value is captured between consecutive powers. So qn less than mn less than q plus 1 n, which means q less than m less than q plus 1. Contradiction, because q, m are integers, and that concludes the problem. So thank you for listening. Have a great day. You had listened to Zeta Factor.